All right, so let's review what we talked about yesterday to make sure we're all on the same page. All right, the first, what's the prerequisite for something being differentiable?
It has to happen, or it has to be continuous.
The function has to be continuous. That's the first thing that has to happen if I'm going to talk about being differentiable. What's the second thing that has to happen if I'm going to be differentiable?
Its derivative.
The limit of the derivative must exist at that point. Okay? When those two things happen, I can say that I'm differentiable. And now we said that differentiable means two things. If something is differentiable, what two things happen? The function is continuous and the derivative is continuous. Okay? So that's the first thing I want to make sure we're all on the same page on. Second thing is, when I'm looking at a graph, I need to be able to tell where I'm not differentiable at on a graph. Okay? The most obvious place I'm not differentiable at is, what did you say? No, beyond that.
I said 0.
No. Where I'm not continuous. If I'm not continuous, that's a dead giveaway that I'm not differentiable. So that's the first thing. Second thing is a sharp turn over cusp. What's going on there? Technically, what's happening at a sharp turn over cusp?
The derivative isn't continuous.
Right, but
An absolute value.
no, before that. The limit of the derivative doesn't exist at a sharp turn. Okay? So we got sharp turn, we got not continuous, there's two other things.
One side, or limit only exists on one side.
Limit only exists on one side, very good, that was worded very good. And the last thing is, no, not asymptote, that's got to do with
Vertical tangent.
a vertical tangent line.
Oh yeah.
Same things happening at a vertical tangent line as a sharp turn. The limit's not going to exist at a vertical tangent line of the derivative. So those are the graphs, and those are the explanations of the derivatives. Now the examples I want to do today, we're looking at piecewise functions and determining if piecewise functions are differentiable or not at a certain point. All right, here we go. I've got g of x equals 8x minus 3. I've got 4x squared. G of x minus. All right, 8x minus 3 for the first function, 4x squared plus 5 for the second part of the function. All right, I want to determine if this thing is differentiable where? At 1. Okay. To determine that, what do I need to do to get started? What must I show first?
If g of x
I must show I'm first continuous. And to show something is continuous, what three things do I have to show?
limit, function value, and if they equal each other.
All right, very good. So let's start with the function value. First thing I need is g of 1. What's g of 1?
5.
G of 1 is 5. Which one do I plug into to get g of 1?
Top.
Top. So I plug 1 in. 8 minus 3 gives me 5. Then I need the limit as x approaches 1 from the right of g of x. I need the limit as x approaches 1 from the left of g of x. So what's the limit from the right? What'd you say, Garrett? 9. What's the limit from the left? 5. So I can stop right there and say
This thing is not
it is not differentiable because it is not continuous. So I'd say not differentiable because it is not continuous. I'm done with that problem. I'll move on to the next. Now, what is really going on with this graph? What's going on with this graph at 1?
It's
It's like the
Jumps.
top one.
It's got to jump. Very good. You guys are right on top of them. Very good. All right, this one I have h of x equals x squared minus 4x plus 8 for x less than or equal to 3, and 2x minus 1 for x greater than 3. So I want to see if this thing is differentiable at 3. But I first, as we did on the last one, must see if it's what at 3? Continuous. So I need h of 1 for, or sorry, not h of 1, h of 3. So what is h of 3? 9 minus 12 is negative 3 plus 8 gives me 5. Then I need the limit as x approaches 3 from the right of h of x, and limit as x approaches 3 from the left of h of x. So what is it from the right?
5.
It's 5 from the right. What is it from the left? 5 from the left. So what does this tell me? Okay, so h of x is continuous. Alright, now that I know it's continuous, what's the next thing I have to prove?
The derivatives are
The limit of the derivative exists at 3. So in order to find the limit of the derivative, what do I have to find first?
The derivative.
The derivative, good. Alright, so the derivative of x squared minus 4x plus 8 would be 2x minus 4. And the other derivative would be 2. So this is x less than. I cannot put the equal on yet. So it's less than 3 and greater than 3.
Why can't you put the?
You'll see why here in a second when I get this finished. Alright. Now that I have my derivative, I need to look at the limit as x approaches 3 from the right of my derivative, and the limit as x approaches 3 from the left of my derivative. Alright, 3 from the right. 2. 3 from the left. 2. So what does that mean?
I'm not gonna say.
Derivatives limited.
Yes, 5. Which means h of x is what?
Differential.
Differentiable. Now, if it's differentiable, what do we say differentiable means? It means two things.
H of x is continuous and the derivative is
The derivative is continuous. Right now, with the way I have my derivative written, is it continuous?
no.
Why not?
Equal signs.
Because I need the function value at 3, which I don't have right now. So I need to go in. Once I know that it's differentiable, then I put the equal sign in there. If it's not differentiable, I cannot put the equal sign in there. But once I know it's differentiable, I put the equal sign in there. Now, does it matter which one I put it on?
No.
Why not?
Because no matter what, it's equal to.
Because what?
Because either function is equal to.
All right, because what's my limit?
2.
My limit is the same place, so my function value is going to be at the same place, so it doesn't matter which one I put it on, I'm still going to get the same function value. This one gives me the piecewise f of x equals 3x squared plus 4x for x less than or equal to 1, and 2x cubed plus b times x plus c for x greater than 1. It says find b and c so that f of x is differentiable at x equals 1. So what two facts do I need to use to help me figure this out, since it says it is differentiable?
That f of x is continuous.
That f of x is continuous, and
The limit of the derivative exists.
the limit of the derivative exists, or what else do I know about the derivative?
That it's continuous.
It's also got to be continuous. So if they're telling me it's differentiable, I use two facts. I use the fact that it is continuous here, and the fact that my derivative is also continuous. Those two facts are going to help me get the information I need to fill this out. All right, so what do I want to do to get started?
Instead of equal to possible.
Okay, I need to do something else along with that.
Plug one.
I need to plug 1 in and set them equal. So if I plug 1 into the top, that gives me 7. If I plug 1 into the bottom, that gives me 2 plus b plus c.
And subtract 2.
Yeah, we can move 2 over, so I get 5 equals b plus c.
And you could either.
Now technically, what is it that I'm doing there when I'm plugging 1 in? To the top and to the bottom. I'm finding the limit from the left and the limit from the right. Okay? So technically, that's what I'm doing. Alright. Now what do I need to do?
You could either do the subtract here, subtract b, and then you can plug things
Alright, but there's something else I've got to do to help me figure out what b and c are. What two facts did we say we needed to use?
back.
The function's continuous and the derivative is continuous. So what do I need to do next?
Could find it.
I need to find the derivative. So that's going to be 6x plus 4 for x less than or equal to 1. Now this time I can put the equal to on there. Why?
Because you know it's
Because I know it's differentiable. Very good. And that would be 6x plus
6x
b.
squared.
6x squared, thank you, plus b, x greater than 1.
Make it set those equal.
So I plug in and set them equal again. Technically, what is it that I'm doing?
Find the
Finding the limit. So if I plug 1 in, that gives me 10. Plug 1 in the bottom gives me 6 plus b. So that means b is equal to 4.
and C is equal to 1.
So then I can come over here, plug 4 in, and we figure out that c is 1. So if I plug 1 in for c and I plug 4 in for b, what does that make that piecewise function? No, I'm not asking you that. What does it do to that piecewise function? What does it make it?
Makes it differentiable.
Makes it differentiable, which means what two things?
Function's continuous and derivatives continuous.
The function and the derivative are both continuous. Very good. Here, I've got a piecewise function. We want to find a and b so that it is differentiable at x equals 2. So Garrett, what do I do to get started?
Plug in.
Plug in, and technically what am I doing when I plug in?
Find the limit.
Finding the limit. So if I plug 2 into the top, I get 4a plus 10. I plug 2 into the bottom. That is 4 minus 12, negative 8 plus b. Move the 8 over. I get 4a plus 18 equals b. Any problems with that? Ryan, what do I need to do next? Take the derivative. So that would be 2ax for the top, and that would be 2x minus 6 for the bottom. So x greater than or equal to 2, x less than 2. Courtney, what's next? Plug in again, and technically what am I doing again? Finding the limit, so I plug in, that gives me 4a. Plug in, that gives me negative 2, so that means a is negative 1/2. So I plug negative 1/2 in here, which gives me negative 2 plus 18 equals b. So that means b is 16. So if I plug 16 in for b, I plug negative 1/2 in for a, that makes that piecewise function what? Differentiable. And Jairus, what two things does that mean?
It means the function is continuous in the derivative.
The function and the derivative are continuous at 2. Very good. All right, again, on the graphs, what 4 things to make a graph not differentiable? Sharp turn.
One-sided.
I can only get a one-sided limit on the derivative. Vertical tangent line, and the most obvious one, if I'm discontinuous.
Oh.
All right, very good.